Here we are! It's time for another JP's workshop, John Park's workshop. Who am I? What are the names of my shows? I don't know, they just blurred together on me. More coffee? Why yes, thank you. Thank you for stopping by. We've got some people over in the chat. Hey, Johnny Bergdahl, Dave Odessa, nice to see you. We have some people over in our Discord. And that's the place to be if you are somewhere like Twitch or Facebook and you're wondering where is the chat happening. That's it right there. The Adafruit Discord is at adafruit.it/discord, and you can head there and you'll get an instant invite, and then you can join in. We've got a bunch of different channels there. I'm just showing this one, which is the live broadcast chat channel, but if I grab these controls here and whoop, show some extras on the side there, you see that? Those are a bunch of the channels that we have. Anything from the welcome to pet photos to help with a bunch of different topics and on, CircuitPython dev. But here we are in live broadcast chat. So stop on by, please. I encourage it. So I'll keep an eye on those chats today, and I'll especially be mindful of noticing when people are telling me that my microphone has stopped working because my batteries ran out last show on Tuesday. Oops. So thanks. There were people screaming at me in the chat, and I didn't notice it for quite a while, so I'll try to pay better attention today. So thank you so much. Let's take care of some housekeeping things. First of all, if you're looking for work or if you're looking to hire someone, you could head to jobs.adafruit.com. This is our free-to-use job board. Let me scoot to the side of it there. There are some new positions that are in here since I last checked. There's some company called Mean Stride Technology in Burlington, North Carolina, looking to get someone to do some contract work, actually possibly threesome ones. Custom module for the RP2040 in CircuitPython, a UART module for it, and an ADC, ADAC, analog to digital control, also for CircuitPython. So what are they up to? That's a good question. Go check that out and see, as well as a bunch of other positions. All you need is an email address with Adafruit in order to use that. There's no fees, there's no charge. You can hire someone, you can put your resume up there if you're looking for work and be found. So go to jobs.adafruit.com and check that out. Let's see. Keeping my eyeball back over here on uh-oh. Almost went down the wrong way. Sorry. What was I going to say? Hey, I've got a show on Tuesdays, and that's called the JP's Product Pick of the Week show. And I like to take a look at a product, either a new one, as was the case this week, a pretty new one, and make some silly photoshops and put together a little show for you where we cover for about 15 minutes, 20 minutes, a product pick. I do some examples, some demo code, wire up something, show it off, and you have the chance to buy it usually for 50% off. It's an Adafruit product. We let them go cheap, and you don't need a coupon code or anything. Just put it in your cart. If it's a popular item, check out right away because they can go fast. This one this week I don't think it sold out, so that was good. And what I like to do is make a little 1-minute recap so you can see what was what. So here it is. It is the LiPo Charging BFF, Best Friend Forever add-on for the Cutie Pie. Take your BFF and you take a Cutie Pie and you just set them back to back like that. Now you can see this example here, I've got some header pins on there. This gives you a JST plug for adding a LiPo or lithium-ion battery. It has a little on-off switch there that you can use to turn on and off the battery power to the board. This makes for really great wearable projects. The Cutie Pie M0 plugged right into the BFF, and I've soldered those with the castellated pads. Got this nice little NeoPixel demo running here. Battery power. You can turn that on and off with the power switch, and we can also charge that right off of the USB. My best friend and yours forever. It is the LiPo Charging BFF add-on for Cutie Pie. Yes, that was it. There it was. And in fact, I've got one that I'm going to be using in today's project because I have found that it's a super useful add-on for CircuitPy, not just for the battery charging. So wait and see some of the other secrets revealed. Stay tuned. Next up, if you weren't aware of it, a lot of these microcontrollers that we use, they can be programmed in a number of different ways, anything from Arduino to MicroPython to MakeCode to CircuitPython. CircuitPython being the fork of MicroPython that Adafruit started, kind of forked it off there, and we've added a bunch of functionality to it and made it particularly suited to adding bazillions of libraries for all the sensors and things that we create and more. It's not just used by us. And one of the things I like to do on the show here is a little nugget of info on using CircuitPython. I like to call it the CircuitPython Parsec. Perhaps you do too. Okay, look at that light show, huh? For the CircuitPython Parsec today, I wanted to show a very simple way to do disco party lights using CircuitPython, in this case on a CircuitPy. So I have a little CircuitPy M0 there, and I've also plugged in a NeoPixel strip for a sort of bonus. This was a Todd Bott tip and trick, actually from his CircuitPy tips page, which we can put a link in the chat. And I've got a nice diffuser here. There's actually a broken light bulb, an LED light bulb. I decided to pop it apart and use that little dome end there as an extra diffuser. But why don't we pull that off while we talk about it here. So what I'm doing in code, all I have are a few libraries I'm importing, including time that allows me to do a little delay. I've imported the board library, which gives me pin definitions, makes it easy to talk to some of the pins on this board. I have imported NeoPixel, which I'm going to use to light up these RGB LEDs. And I'm importing random integer, randint, from the random library. And then I'm setting up two NeoPixel objects. One's called Pixel, and that is the NeoPixel that's built right on the board. So we address that by saying NeoPixel.NeoPixel board.NeoPixel. That's a lot of NeoPixels. I have one, so that's the one there, one NeoPixel on the board, and I've set the brightness to 0.2. The second one is actually this strip of 8 NeoPixels, and I have that plugged into the board's STEMMA QT connector, so I'm using the serial clock, SCL. And then I have 8 pixels on that one, and I've set that a little dimmer since there are so many LEDs there, a brightness of 0.1. Then in order to make this kind of cool disco show, what I've got going on are 2 instances of pixel fill, one for the pixel, one for pixel strip. And every time we loop through, I set a different random integer for the red and the blue component, leaving green at 0. So that means I'm going to get anything from red to blue to all the magentas and pinks and so forth in between, purples. Then we pause for 0.2 seconds and repeat it again. So we get this really cool little disco light show here that I really like. It's really simple to use, and I hope you like it too. And that is your CircuitPython Parsec. I should say, that is how you can set up a disco light show on your CircuitPy using CircuitPython. That is your CircuitPython Parsec. Wow. Wow. CircuitPython all right, we'll get that out of the way there. And fielding a question from YouTube, Dave Odessa said, "What's in your coffee, JP?" And the answer is pure energy. All right, so let's see, what else have we got going on here today? I wanted to give an update, and I completely forgot to bring it out here. So I'll do a little demo of it next week. And you may have seen it. I showed the alarm, the RPi locator alarm I was building last week. I showed it on the show and tell last night. I put it together last week live on air. It had a problem booting up after I soldered everything together. I did not find the problem in time, so I ended the show. And then within about the next 60-second time period after the show ended, I got a little closer look at it under my microscope, and I saw one single strand of the twisted stranded wire I was using, that silicone wire, this stuff right here. I really like this stuff because it's nice and flexible. However, I didn't tin the ends of it, and so I had a little stray single strand touching the next pad over from where it was intended. So I was essentially shorting, I think, the USB 5 volt over to reset. which caused it to not burn out the board, thankfully. It just never wanted to turn on. It didn't cause any problems with the code once I was able to basically move that little wire out of the way using a dental pick under the microscope. And then clipped it, actually. I was able to get the clippers in there. It solved it, so it works just fine. That, however, is my tip. My learning from that is make sure that you tin the ends of stranded wire if you're going to use it. And typically you like to use either enamel-coated wire for very small work, it's a single strand, or solid core wire, which is not as flexible, which is why I went for that nice silicone-covered wire, but that is a stranded wire, so that can cause problems. So let's see. Yeah, I'll show that on next week. I'll show that working. But Liz, thanks so much, Blitz City DIY. She and I have been working together on some code updates and troubleshooting and bug fixy kinds of things. So it's improving even now as we speak. The guide is live, however. In fact, let me show that. Let me head back over here. Here's the guide. I'll put my face over to the side there, and how about like that and like that? That ought to work. So here's the final, and this is what I was building on the show last week. You can see I've got a little GIF animation playing up here in the corner that shows it in action, and there is a section of the guide just on installing CircuitPython on the board. This is the Feather ESP32 S2 TFT. Then we have the code here. So this shows you, this is the full code. And you'll also use a secrets.py file in order to give credentials for your Twitter API, for your Adafruit I/O, which we're using as a time server, and your Wi-Fi. So this can connect to Wi-Fi. And this tells you how to upload the code, shows you which libraries you'll have there. Thanks to Liz for putting this page together. We have a nice image there of all of the libraries that are at use. And the bundle download, if you let me scroll back up here, if you click on this download project bundle button, you will get all of those libraries downloaded. So you can just drag them right over, or you can use CircUp. I really like to use CircUp to get the latest, freshest ones, if necessary, although that bundle will update itself automatically. And there's a little explanation of how the code works. And it is essentially checking the Twitter feed using the Twitter API of rpylocator.com. If it sees the keywords in stock at Adafruit, then it will, and you can see that right here, it says query in stock at Adafruit. If it finds that, then it will set the alarm off, and it'll display the text of the tweet on the screen. That's what you're seeing up here in the little corner there. First it says no stock, then it finds it, wee, 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 very loud alarm on there, and now it says stock alert, and this is the copy from the tweet there. And then for the build, you can see here, that's what I built last week on the show. Here is the fritzing diagram for it. And there is the actual build there. It was actually the red wire that you see there in the image. If I click on that, this red wire on the underside of it, I had one little stray strand. In fact, I think I have an underside shot of that. There he goes, the big version of that. Go to the original. And I think it's this one right here. This had a little stray wire poking through, so that was my problem. The rest of it goes into putting that together, just test it out, build your 3D printed stand if you want, or you can use cardboard box. I had shown that box that comes with this. That's what the alarm comes in, and I had originally figured out some of the geometry there by poking holes in that, which is a nice way to prototype that. So a little fancier version with a 3D printed stand. And then we use some of our little nylon M2.5 hardware to attach that. You can see we've got some of those little standoffs on the bottom there so that these two can mate together nicely, sandwiching the 3D printed stand. and then feeding the wires through using a little terminal block here so that we get a nice connection. Plug it in, and off you go. You're ready to use it. So that was the product, rather the project last week, and the Learn Guide is out now. You can go check that out. Yanisku in our chat with the excellent be-doo, 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 be-doo GIF. I love that. And that covers that. So now I want to get to a new project that's sort of revisiting something I had done before. I'd originally built this to test it out, and I demoed it a little bit, but I don't think I've ever gone into the specifics of the build and the software that much. This is a Feather ESP32 version 2 Huzzah. So it's not the ESP32 S2 or S3 or RISC or any C3, any of that fancy new stuff. This is, on some of these it's the Pico. This one is just the V2. We have on this board the A0 pin set up in an Arduino sketch, and I'll show you the software for that. We have it set up to put out composite video. That's the old school yellow video cable plug. Let me see if I got one. Got one right here from a different type of connector, but that right there, that's the socket side of an RCA connector, which is used for a lot of older TVs. And by connecting ground on one side and the A0 pin on this, we were able to send out some video to an old school monitor. Now the monitor can be fairly modern. This one's probably 10, 15 years old. It's an old, I think, Westinghouse LCD that happens to have composite input. A lot of our little Adafruit displays, little HDMI Raspberry Pi displays, have a composite input. Some of my old CRT televisions do. And I actually have this really cool new beast. Let me jump to the overhead for a second to show off this thing. This new old thing, this was made around 1989. And this is, let me see if I can get a little, there we go. This is a Sony Video Walkman that was for playing your 8mm cassettes, and it has a TV built in, UHF, VHF. It has a cassette. Let me turn, there you go, pop the cassette open there. That's not working. There are issues there, which is pretty typical for cassettes of any kind. After a while, the belts wear out or other problems occur. But it does work as a composite video input. So I'll do a little demo on this of this week's project, and then I'll pull out the nice little Sony CRT television that I have, I think it's a 13-inch one, to show it on there too. This is a little LCD panel, nothing to write home about, but really impressive for 1989 technology. You can see here we've got video in, audio in, there's a video out, audio out. It has a camera input for some sort of funky connector. I probably have that on my Sony Hi8 camera actually. And then you can select between the line in, the camera input, or TV input, try to tune something in. Even has a cool little antenna on here for trying to pick up television, but in my tests so far I got nothing. There's a lot of mountains around here, so hard to pick up. Then on this side we have a plug for an external antenna that may help, a VHF, UHF switch, and then a bunch of other controls for setting clock and things like that. So this thing could be used just to play movies, as well as record stuff, record off a TV, use it to record off of a camcorder. And I even saw on some, I was researching it a little bit somewhere, I saw that at one point, I think Virgin Airlines or Virgin Atlantic was giving these to passengers in first class to use to watch they could pick a movie from some folder of Hi8 or 8mm tapes and watch a movie during the flight, which is kind of hilarious. I do have a battery for it that I think probably doesn't take much charge yet, and then I'm running it into a little adapter. So cool little gizmo, and I'll show that with our project in a second here. In fact, let's fire that up. So what I've got here is the Evolutionist project. So now this is our ESP32 Pico. Zoom in real close there. Is that too close? This out of the way. So there's our ESP32 S2 Pico. You can see it has a simpler little package than the ESP32 version 2. It's not in the little can. I don't even know where the antenna is on it for Wi-Fi, but it does have Wi-Fi. It does work. I'm able to log into this. Sorry, let me get that glare off of there. And set the time. So what I've got right now, just for testing purposes, is super janky, but I've just taken some of these little jumper alligator clips, and I'm running them from ground to the sleeve outside part of this RCA connector, like that. And then I've got the center or tip going to the A0. And let's give it some power. So I'm going to steal a USB-C for a second here. Excuse me. I've just got this running off of a battery pack. And what I'll do is, other end of this cable here will go into camera in. I'll go ahead and plug this in to power, so that starts up my little cutie pie there. I'll turn power on the screen here, and hey, look at that. Sorry, it's not super bright, and especially with the glare here. I don't know if I can. It's got some color and hue controls. Actually, I don't know if it has a brightness control without digging into menus. But there you can see I've got the time. It's not the accurate time, so to set that right now, what we'll do is see if I can connect to it over Wi-Fi from my phone. There we go. And let me just make sure I don't have conflicting, there we go, conflicting devices. So let's pull this over here, get that in camera. Okay. Pretty good. I'll zoom out a little bit, actually. I don't need to be that close. All right, so what I'll do is on my phone, I'm going to disconnect from my current Wi-Fi and connect to a Wi-Fi hotspot that shows up called ESP32 Dolly clock. And it's one of these captive Wi-Fi things that I can't remember if I need to go to Safari to see the page show up. I may actually have to forget the network. Let me do that. So I'm going to forget this network. Sorry, I know this isn't too exciting to watch. And now try to reconnect. Sometimes that'll pop up the that little web page that this thing is serving up, little captive web page. Sometimes I think I've had to go to Safari to make it happen. Let's make a new page. And what does it think it's doing? Oh, that's weird. Why is it acting connected? Oh, it has not connected yet to that. That's why. Sorry, it's trying. Let's try this one more time. Okay, so you'll see here, here's this Dolly clock. Click on that, and now we're waiting for ESP32 Dolly clock to, there we go. That time it popped up. So I've got this little Dolly clock interface, and I can do things like set the color scheme. So you can see this just turned to blue. That can adjust based on time of day. I like the dawn one, which has that nice warm colors. Got gold in there. Okay. And then I will change the time, and it'll just use the current time. So there we go. That's my local time, 1:28:03. So easy as all get out. You can also set up a network, your local Wi-Fi network and password in order to try to have it automatically use the time server. I don't know if I've gotten that working actually. I'm not sure if that's working currently. But that'll work right there, so that means I can log out of that and just get my phone back onto my local network. So that'll require power to remember that. I don't think it writes any of that info. So one of the things I was thinking about is how can I improve this thing, make it a little less goofy than what I've got here with all these wires going on. So what I want to do is find a way to connect this up to battery power, make it a little more elegant as far as connections go, and turn it into kind of all-in-one thingy. So before I do that, actually, I just want to check my my chats here because I don't see them over there. Make sure everything's good. Looks like we're good. Okay, so let's rather than build this, just because I don't. Besides being semi-gun shy because I screwed up the one last week, but at the end of it, I also realized it's not a very interesting build to see someone make, but I think it is kind of interesting to see what I ended up putting together here. So what I've got is, clear some stuff out of the way here, and I'll unplug that and remove power. So that's the one. I'm actually not going to use that one for this. I've already got one built. And I'm not going to need all those wires anymore necessarily. So what I've got, that is our BFF. That's the charger BFF. And you can see here I have soldered some pin headers to it, socket pin headers on the bottom of it. And that, you can see, works pretty well with how these can go belly to belly like this. And one thing you can't, my camera won't focus close enough, I don't think. Let's see. That is about as close as that's going to focus. So I have these soldered into the actual pin holes or pad holes, drill holes on the board. It means we still have the castellated pads on the side to solder things to, which is what I'm going to do on the other one in order to make a connection. But right now I've got the BFF here. This will provide power. It also gives me this convenient on-off switch. And it acts as an uninterruptible power supply. So if I'm running USB to the CircuitPy, if I unplug that, if there's a power surge or whatever, this will take over and provide power off of a LiPo battery. So I can take pretty much any little or big LiPo. In this case, try this one here. Actually, I think this one is still good. I started to feel some loose wires there. I'm not sure if it's... Yep, I just broke them off. So those were on their way out. It got bent too many times. So that one I may be able to solder to and save that. But we'll use this one. It's a nice little battery here. Give us a ton of time on here, 420 milliamp hour for this thing. The CircuitPy, what I am going to do, and we'll do this a little more cooking show style. So what I came up with for this is we've got these extra long headers. And so they're sort of standard header length plus a little. You can see there it's about a 0.5 millimeter longer on one side and a whole lot longer on the other. So what I decided to do is take, and let me dummy up one of these. So I'll take a section of 7 of these. And why am I making this extra long? It's because I want to fit an RCA connector, either this socket type one or this pin type one, in between the boards. And so you can see there, this is too tall to accommodate a normal length of header and still have the board rest on top. But with this super long one here, we'll be able to get the length right where we want it, or the height rather, right where we want it. And it means we can have an all-in-one little composite video nub that we can plug into things. And also gives me, at the top here, I've got some, so you can see that, I've got some extra pin on the top there that I can solder my A0 and ground wires to that are going to run off of this. So they'll come out and connect to the 2 wires necessary and then go into the screw terminals here. And then what I decided to do to make it just a little fancier is I took a section of this cool yellow header and I pulled all the pins out and added a second row of the header spacer there like that. And so once that's all put together there, you can see here this was the extra long header there with extra spacer on top. And so that's soldered into the CircuitPy Pico, ESP32 Pico. Means when I rest this, just got to get the sides right. So the JST side for the battery is the same as the USB side. You got to remember that. But that means we get a really nice snug fit there. It's just a little gap there, but these are bottomed out, and that is now pretty much exactly the size of spacer we need to fit our little RCA. And so that, again, can be either the socket side or it can be the pin side. Now, the reason I decided to go with the pin side here is that this can be plugged directly into things. So you don't need any extra cable, so you can plug it in like that. But what I really want to do is this, like so. Okay, and we can still plug in USB-C there, but I just have these running back and up. And there might be a way to do that on this side of the board, but I found this was pretty decent for a first go. And so now if I connect up my BFF there, this is sandwiched right here. And if I find a sort of position for this that I really like, I could even just use a little bit of hot glue or another adhesive to attach the RCA board to the bottom side of the BFF, which just is bare PCB. There's no components there, so it's a nice flat side to attach that to. So this now, with a battery plugged into it, can be shanked right into. Let me zoom this out even more. Let's turn that power on. Whoop! And now we've got our clock. So if you used this one of the reasons it fell off is I was bending it back on itself, which is always a little delicate with these batteries. But if I pull that back there and use a smaller battery, you can see we could attach that right to, or maybe even heat shrink the whole blob of it. But now we have this clock. I need to set the time on that, and since so it's not correct time right now. If I set the time on that with the web Wi-Fi web page that it pulls up, the captive host web page, then it will, as long as I leave this turned on and the battery plugged in, it'll stay on. Then I can go ahead and power this from USB-C. So that is going to charge the battery while it powers the board until it's done charging, and then it will stop charging the battery there. But this is really cool, so if you're using something more permanent, you could have it on USB, and you're never going to lose power to it because of the little battery based on the BFF. It also gives us a really nice way to hook it all together. Now, one other reason that I really like this type of pin connector on this is that, rather than the socket, is that we can use an adapter. Where'd it go? This is one of my little handy adapters, courtesy of C. Grover in the chat, who gave me a whole bunch of audio, video gear extras from his studio at one point. And so this one will convert this over, and now we can plug a cable into it, which is really common to find this type of cable like this. In fact, I'll strip this one You can just pull these apart, and now that's a stereo audio pair there, and this is just your typical composite video cable. So we can plug into that on this end, we can plug over here into our TV, and off we go. So that gives you a lot of versatility, particularly if you need to get to this and the TV has a cable off to the back. So last thing I wanted to do, just because I think as neat as this little video Walkman is, turn that off now. Whoops, that's not off, that is. I really prefer seeing this on a CRT television, which was the original point of this for me, was having something cool to display on a CRT. So let me zoom out a whole bunch here, and pardon the mess here. I'm going to just clean up a couple things real quick. And we'll get my cool sidewalk find Sony CRT. Set that right there. Let's plug that into power. And now I can use my little cable and adapter there to run that to video in, and now we get lovely Dolly clock there on the CRT television. Look at that! Look at those viewing angles. Whoa! Doesn't like me yanking on the cable. I think that cable's a little loose. So I won't bother trying to set the time on that again, but I'll leave that there while we just take a look at the code. And over in the chat, Todd said, neat sneaky little video injector. For sure. I think there's an additional project that Lamore asked me to look at doing using this as a video generator. And so if I do it on the CircuitPy, it'll definitely be like a neat little nub that you can plug in just to get some video. One issue I've noticed is I've got this jitter, if you can see it there. Let me go to the main cam for a second. I can zoom in there. Pardon the camera. There we go. You can see that little jitter there. In fact, leaving the little video one overlay there, you can see it pretty well. That was not happening with this previous version. Where did I put it? This one here. In fact, do I have an easy way? Yeah, let's take a look real quick. I think that this one didn't have that problem, so I'm not sure if this is an issue with the CircuitPy for some reason, which is a slightly different chip. It might be less happy. So this is great for my needs. I don't mind that jitter, but for the project Lamore was asking about, I may end up using this feather instead. So let me find a ground, and I'm going to unplug here. So you can see this one is locked rock solid, other than I've got a scan line issue there you see crawling up. And that issue was happening on two different CircuitPy ESP32 Picos, so I don't think it was a fluke. I suspect there's something going on here, and maybe it can be tuned. Maybe there's clock settings that can be adjusted, but I've got this little sync wobble kind of thing. I'd love to know if anyone has ideas about that, where to check. And in fact, that's a decent segue to, let's check out some code for this. So let me bring back Adam here, and I'm going to open up an Arduino sketch as well as one file that we alter to make this work. I'm also going to turn off my little disco show over here because it's distracting. So where did you go? Okay, so hold on one second while I open up this Arduino sketch. Where are you, Dolly Clock? There you are. And I'm also going to open up inside of the supporting files. There's this file called compositeColorOutput.h. So I'll write up a little guide about this. This project, I'll show the web page for it in a second. This was written for some other ESP32. I can't remember which one. Hey, that's a good question. Sorry, someone in the chat, QSWAGS, said, could it be interference from the TV being on top, the thing being on top of the TV? I don't think so. I've tried it pretty far away, so it's a similar circumstance, and it's the same over USB or battery. So I don't think it's that type of interference, but good question. The only change that I really had to make for this code, and this goes back a few years originally, I think, to when the ESP32s first came out, was the pin here, and I'm using GPIO 26, which equates from that Pico or the V2 ESP32. That equates to pin A0 on both the Feather and the QT Py. I'm not using audio, and I don't think there is a pin 18 broken out on there, so if someone wanted to see what's going on there and adjust, then you just want to pick a different pin that's broken out on the QT Py to try that, or the Feather. So once that file is updated, then there's really nothing else to touch. This is, you can see here it supports NTSC and PAL. I don't have a PAL TV to try that on, but supposedly that does. And let's see, anything else? Yeah, I don't know if there's much to adjust here. There's a bunch of cool configuration options for the graphics on this one, and there are other projects that use the ESP32 as a composite video out that are worth looking into, and I'll link to those once I put together a guide on this. So I don't have too much to talk about in the code. Really, the only thing was just for me to get it working, I just had to figure out what pin to send the video out over, and I think that differed from the original. Let's see, another suggestion from the chat. Todd says, could it be the LDO voltage regulator droop? Could be. Noise from the BFF. Lawrence, I had this problem without the BFF involved because I had that one bare QT Py that was just plugged into USB power. Yeah, and I'm running that Feather that works there off of a LiPo battery, so I don't think it's a difference between like mains to USB versus USB battery pack to USB power. So, not sure. If you look into this project, there are a lot of different files where you can go and look and see if there's anything about some of the timings that might be adjustable. Oh, another suggestion from Todd there is if it's the voltage regulator droop, I could try powering it from a clean 3.3 volt to the 3.3 volt pin from a strong supply. All right, I'll take the bait. Let's try that. Let me switch over to this camera here with a little side of that. Let's see if we can do that. So, in order to do that, let me move some stuff, and I'm going to turn on, I have a nice benchtop power supply here with short-ish cables on it. Let me extend those a bit. Hold on. And I think I have my camera remote over here. No, that's not it. Where'd it go? Not surprisingly, it's lost because I have a mess over there. All right, let me just zoom out here. Okay, so if I take this guy right here, and maybe I'll do that where you can see it on top there. So what I'll do is I'm going to turn this off. I will remove the BFF. And I will connect my little power leads here to the power supply and feed it a really nice 3.3. Try not to short things, that would be great. Okay, before I turn this on, I will double check the chat to see that no one has concerns before I actually do this. So, all right, so my channel 1 is set to 3.3 volts. It's off at the moment. So I'm going to connect up to the 3 volt and the ground. Hey, what's this wire? That's no good. There we go. Now I'm very, very paranoid about whiskery little wires. What that's doing there. I will even check for continuity before I turn that on because I'm paranoid. I only have 2 of these little cutie pies. I don't want to blow them up. Well, am I really grounding, or am I really shorting that, or is that just, let's see, without that connected? Sometimes you just can't measure things in circuit. Yeah, those are, that's ground, that's ground. Yeah, I think that's fine, I just can't measure that in circuit. If you are screaming at me right now, no, don't do it. I will see your screams before I turn this on, so I will go check the chat. Huh. Yeah, my little probes here, these are nice Pomona probes, and for some reason they've got, sorry, let me switch the cameras here. For some reason they've got little tiny wires escaping the ends now. What the heck happened? Who knows? That should work. All right, I'm going to check the chat. And I'm either going to smoke this cutie pie or we'll be okay. CircuitPython page warns the larger boards can cope using the DAC, but not the cutie pie M0. Yeah, okay, so this is a cutie pie ESP32 Pico. Super duper user says, very cool project. How can we use the cutie pie to play a looping video on a portable screen like a 5-inch one? That'd be excellent. Yeah, really cool. There's a lot you can do with this. All right, here I go. I'm gonna power that up. Let's see what happens. Crossing fingers. Hey! Still jittery? Yes. I'm powering that now from a really nice benchtop power supply. And yeah, that is still jittering up and down. All right. So could be we're pushing that little fella, a little Pico, beyond where it wants to go. Could be something solvable. Who knows? But I don't mind it. Really cool for the clock. Hope you enjoyed that too. That is the project of the week. I will write this up, and I will also include info on just using the Feather ESP32 V2, which is identical. There's nothing to change other than flashing your Feather board. I could probably also make a pre-compiled UF2 file, so you can throw that on there if you put the bootloader on there through CircuitPython. Make it easy, but that is the project. Oh, before I go, I did want to say I want to point out the original project, ESP32 Dolly clock. If you just Google that, ESP32 Dolly clock, that is at Marciot, M-A-R-C-I-O-T, /ESP32-Dolly-clock on GitHub. Here's the project. Looks pretty familiar, right? And lots of info about it. Look at that great TV they had it running on. Beautiful. There's even some info on wiring it for the ESP32 Huzzah, which is essentially the board I'm using. And there's some advanced configuration things. Maybe if I dig through this, I'll find info about the timing jitter. Lawrence Harris over in our chat on YouTube says probably timing jitter on the vertical sync. Okay. David Essa says if you smoke the cutie pie, you can always get one at half price on Pick of the Week. Excellent. All right, I'm a big fan of this project, so thank you so much to the original author, who also thanks BitLooney and a few other people for pioneering the work in doing video over the ESP32. BitLooney and who else? Rossum, I think, was the other one. So thanks everyone who was involved with that. I think that's going to do it for today. So thanks everyone for stopping by. I will see you back on Tuesday for another product pick of the week, and next week for another episode of this. Maybe I'll have worked that out in time. I also have a couple other projects in mind that I'm working on. So that will do it. Tomorrow should be a live stream deep dive with Tim. And I believe Scott Shawcroft, Tan Newt, is going to be doing some streaming here and there. So keep an eye out for that. If you're wondering when shows are generally scheduled, you can head over to our Discord right there and type in show times, and that will give you a nice little list of the generalized ones. Those are not updated. If someone has a reason to not do a show, that might not be updated, but you can check around, ask around on our Discord for that. Okay, is that it? Have we done it? I think we've done it. Thank you everyone for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Goodbye.